In this video, I'm going to attempt to teach you the fundamental of a distance between a point and a line in a very short time. Let's sink into the lesson. First, we are going to prove that D is equal to ax1 plus by1 plus c divided by the a squared plus b squared. So, but you are given a point x1, y1 and a line. The equation of a line is given by ax plus by plus c is equal to 0. So if we try to sketch, this is the line and this is the point. So we're going to find the distance from this line to this point, which is given by D. So first you let P2, x2, y2 be the foot of a line L perpendicular to the line. So you let P2 be the foot of the line and the point, which will be P2 is equal to x2 into y2 into bracket. Therefore, we are going to find the gradient of this line. So it is going to be ax plus by plus c is equal to 0. Meaning y is going to be is equal to ax. If you move on the other side, it will be negative ax. C, if you move on the other side, it will be negative c divided by coefficient of y, which will be divided by b. Therefore, m1 is going to be negative 1 over b, which is the gradient of this line, the line. Since L1 and L2 are the perpendicular, then m1 times m2 is equal to negative 1. Now m1 is the gradient of line 1, so it's going to be, which is negative a over negative b, which is going to be m2, negative 1 over negative b multiplied by m2 is equal to negative 1, which implies that m2 is equal to negative 1 over negative 1 over b, meaning m2 is going to be b over a. From L2, gradient is given by change in y over change in x. So we are going to determine the gradient of this line, the line L2. So it's going to be y2 minus y1 divided by x2 minus x1, which is equal to b over a. So this is going to be y2 minus y1 and x2 minus x1, which is equal to b over a. Then from there, b came, because here we are not going to do cross multiplication. Here we are going to take the value of x2 minus x1, we divide direct by a, and which will be the same as the value of y2 minus y1 divided by b, which is equal to, you can give any letter. Here I take q, you can even let to be r, can even let to be m, but I decided to use q. So x2 minus y1 over a is equal to y2 minus y1 over b, which is equal to q. Then from there, meaning x2 over a minus x1 is equal to q, meaning x2 minus x1 is equal to aq. And y2 minus y1 over b is equal to q, meaning y2 minus 1 is going to multiply b times q is going to be bq. From there, we can say x2 minus x1 is equal to aq, and y2 minus y1 is equal to bq, which we get it as equation 1. Then from D, P1, the distance from P1 P2 is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. So we are going to define distance from here to here. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. But we already said that x2 minus x1 is equal to aq. So we are going to replace x2 minus x1 by aq. So it's going to be aq squared plus bq squared square root. So if we factor out here, it's going to be a squared plus b squared into bracket multiplied by q squared. Therefore, a squared plus b squared is going to be, if you square root q squared, is going to give you q, but you put it into moduli. This is going to give you equation 2. Since P2 is x2, y2 into bracket is on the line L2. Then it satisfies the equation of the line L1. So ax2 plus by2 plus c is equal to 0, which is equation 3. From equation 1, which we already said that equation 1, we already said that x2 minus x1 is equal to aq. And y1, 2 minus y1 is equal to bq. So x2 is going to give you, is going to be aq plus x1, and y2 is going to be bq plus y1. Substituting the above equation into equation 3. So we're going to substitute this equation into equation 3. We can get, so where there is x2, we're going to put aq plus x1, and where there is y2, we're going to put bq plus y1. So it's going to be a into the value of x2 is aq plus x1 into bracket plus b into the value of y2 is going to be bq plus y1. So you put into the bracket plus c is equal to 0. Let's open the bracket. So it's going to be a times aq is going to be a squared q. You add a multiplied by x1 is going to be ax1. You add b multiplied by bq is going to be b squared q plus b multiplied by y1 is going to be by1 plus c is equal to 0. So you collect like times. The value which contain q you can factorize. So it's going to be q a squared, and this one also contain q. So it's going to be b plus b squared into bracket. ax1 is, its move on the right hand side is going to be negative ax1, and by1, if you move on the right hand side, it's going to be negative by1 minus c. So q is going to be, if you, since this function it's contain negative, both contain negative, you can put negative outside. So it's going to be negative outside ax1 plus by1 plus c into bracket, and divide by a squared plus b squared. So meaning if we want to this negative to disappear, we're going to do the modulus. So it's going to be modulus ax1 plus by1 plus c into modulus over a squared plus b squared, which is going to be the modulus of q. Substituting the above into equation 2. So we're going to substitute it into equation 2. This is equation 2. So it's going to be d is equal to a squared plus b squared multiplied by lambda modulus of q. So d is going to be a squared plus b squared, then modulus of q is ax1 plus by1 plus c divided by a squared plus b squared. So this is going to be, the square root is the same as a half. So it's going to be a squared plus b squared raised to a half into modulus ax1 plus by1 plus c divided by. Here we're going to do nothing. So by doing nothing, I can say a squared plus b squared raised to a half plus a squared plus b squared raised to a half. If you open here the bracket, it will bring you back to a squared plus b squared. So this one is going to get cut with this one. So you are going to remain with ax1 plus by1 plus c divided by square root of a squared plus b squared. Hence it will be proved that the distance between a point and a line is given by d is equal to ax1 plus by1 plus c over the square root of a squared plus b squared. Thank you for watching my video. On the next lesson, we are going to know how to use this formula and how to solve that question in a simple way. Thank you for watching my video. Welcome for the next class.